Hello guys. It's been a very long while and I miss you guys. You all know that I wouldn't actually be here for no reason. Um, I do have this one problem that somewhat might have pop up as some little no big deal. All right, the irony. Okay, so we're going to check it out and then see how to go about it. Let me take you to our presentation. Oh, great. This never gets old. Just Lipolima with just still precious. And I'm really glad that I'm here once more. It's been a while, with all this craziness and hassle going on with work and external exams for senior secondary students in Nigeria. Oh, you all know what I'm saying. JAM and WAEC or WASSCE, all that. It gets really, really tight for my schedule. Okay, so let's check out what we have here today. Um, okay, so this is a question on trigonometry, and like anyone would guess, I'm looking at an isosceles triangle that is ABC triangle ABC. This is isosceles because it seems to me that the base angle are equal, and for the fact that they are equal, how do we go about finding the values of x and y? Um, I don't think this can be easily pulled off because it's vague. But I could start off with the basic. I could start off with the sum of interior angle of every triangle is equal to 180. And for triangle ABC, the the workout there would be angle angle A plus angle B plus angle C, which would give you equal to 180. To me, angle A is the x and y value, while angle B happens to be 70 degrees in total, and angle C the same thing, which happens to be 180. So if we have 140 on this side of the equation, plus x plus y, and all resulting to 180 degrees, we could subtract 140 from both sides. You all know the rudiments to this. It's not a big deal. I think this is the easy part. So we find out that x plus y is equal to 40 degrees. I'd go on to call this the first equation. Okay, so what's the next thing? I think this is a little bit the hard part because at this point you're going to be looking out for what the equation 2 is going to be, and pulling it off might somewhat be challenging here. Trust me, I have tried several methods and I'm still open to newer methods provided there is. But the one astute way I figured we could go about this is I could show you, but let me try labeling this triangle for what it actually is. Okay, I'm trying to find some good colors to label with. I'm going to call this straight line between A to O. I'm going to call it alpha. All right, that's going to clean. Well, alpha, you get the point. So this one we call it better, and this one we call it lambda. Okay, so this labeling will help us develop the second equation, trust me. How am I so certain about this? I wouldn't come unprepared. That's one thing. So let's go back to our normal color, black. And I think I would like to circle out on this. Okay, so the next one would be using the sine rule. We're going to use the sine rule. We are going to be like, okay, watch this. For triangle, for triangle B, okay, that would clean. For triangle B, A, or something, yes. We're going to have something like, this is the sine rule that I'm engaging here. Alpha all over sine. The opposite angle to alpha for triangle BAO would be 40 degrees, is equal to, I have better all over sine. To me, it appears we know that it is x, and I kind of would call this a construction equation. It's not like the main equation, so I'll call it equation A. And then for triangle ACO, or let me go about it differently now. AOC, we're going to be having something like alpha over sine 30 degrees is equal to, okay, lambda over sine y, definitely is. I'm calling this equation B. Okay, that will clean PowerPoint programs. And now I have, for triangle, I'm concerning that part. For triangle, which is the last interior triangle there, for triangle BOC, we're going to have better over sine 40 equals lambda over sine 30. Okay, this is nothing too confusing. I believe you already know how we came to this point, and as long as it's going to take us to find the values of x and y, I would like us to start by saying making alpha subject of the formula in equation A and in equation B. If you were to make alpha subject of the formula in equation A and equation B, of which that will be in this and this, if provided you find it difficult making alpha or making any particular item the subject of the formula in an equation, probably you should subscribe to my YouTube channel and stay tuned, because I upload lectures on briefings like this. So making alpha subject of formula in equation A definitely would give us something of this nature. Alpha equals beta sine 40 over sine x. All right. And we all would call that equation AI. So, and then for equation B, alpha would equal lambda sine 30 all over sine y. So we could call this equation BI. So at this point, I would say let's substitute equation AI into equation BI. So that would mean beta sine 40 over sine x is equal to lambda sine 30 all over sine y. Okay, this is the juicy part for me. It becomes very exciting at this point. So, I think this is pretty much it. And what we'd want to do now is make beta subject of the formula. So make beta subject of the formula. It's obvious that this board is not going to be enough. Maybe we'll try something. So beta definitely would be equal to, okay, right. Okay, I'm trying to see a way to this. Okay, yeah, sorry. It would be sine 30 sine x all over sine 40 sine y. Okay, that is it. This is better for what it is. And right now we are going to actually make beta subject of the formula in equation C. At this point, it's just getting a little hazy. I'm stressed out from the day's work, and we are going to make beta subject of the formula from equation C. Okay, so let me go into some space for this. As if you have imagery of previous one. Okay, so beta over sine 40 equals lambda over sine 30. So okay. Sorry, let me activate my pen. Beta over sine 40 is equal to lambda over sine 30. So making beta subject of the formula, that would be beta is equal to lambda sine 14 over sine 30. So let's go into the previous this. So at this point, the last part of what we've done, I'm going to call it, I'm going to give this label a name. I'm going to call it equation AB. So why I'm saying that is because we are going to substitute, sorry for that. Why I'm saying so is because we're going to substitute equation CI into equation AB. Either ways, the commutation still would give the same effect. So that would mean lambda equal, okay, sorry. So that would equal lambda sine, okay, lambda sine 40, definitely 40. Lambda sine 40 sine 30 is equal to lambda sine 30 sine x all over sine 40 sine y. Okay, at this point, I think lambda will cancel lambda, definitely. And this point, let's say we're collecting like terms, generally, that would be something like this. Please, just watch. That would be sine square 40. Then for sine 30, we have sine squared 30, all equal to sine x over sine y. Okay, this is getting pretty long and exciting the more. And right now, I want to take you back to the equation 1. Definitely, it's something you should remember, provided you've forgotten it. The equation 1 says this, x plus y equals 40. So if I were to take that, it would be, since x plus y equals 40, I'm going to be like x, making x object of the formula. Making x object of the formula, that would be x is equal to 40 minus y. I can call this equation. Please, may I have you guys know that this is my equation 2. I might call this equation 3, of which I could just say, right, fine, since we're in equation 3, you already know what I want to do. I'll substitute equation 3 to equation 2. Which would mean sine, wherever I see x, I replace it with 40 minus y, bracket close, all over sine y equal to sine square 40 all over sine square 30. So at this point, we already know the trig identity. And in case you didn't know the trig identity for sine of difference of angles, I might recall it for you, provided you're not aware. So it goes like this. If we have sine of angles having B subtracted from A, it would also have the same effect as sine of A cos sine of B, cosine of B, alright, minus cos A sine B. And if that were true, for this numerator on the left hand side, it would mean sine 40 cos y minus cos 40 sine y all over sine y. You all know how fraction works. Please don't make me explain. Is equal to sine square 40 and sine square of 30. At this point, on this side, sine will have to cancel out sine, and here we're going to have cosine y over sine y, and then sine 40. Okay, I don't know if I have to make it a long process, but I'm exhausted finding just the value of y. And as excited as I am about this, maybe I would want to make it easy for every one of us. So you could take a break, come back whenever you want. Just that the question would necessarily not take a break until it's solved. So I'll just head back onto it. At this point, I need not tell you what we are going to do. We are going to isolate cosine of y and sine of y from the trig ratios that have real numbers. I don't know if that makes sense, but to me, doing that would entail, right, let me show you this. At this point, we're going to be having something like sine 40 cos y over sine y minus cos 40, all equal to sine square 40 over sine square 30. At this point, I would be like, all right, no problem. To me, it's more like, oh, collecting like terms. And that would look like this. Okay, sorry. Control. Okay, that would look like this. Sorry, let me mark on my pen. So I would have cos y over sine y, right, is equal to, please, sine square 30 is equal to, please watch how this goes. Sine 40 here, we take a little bit of sine square 40 here, leaving us with just simply sine square 40. It's just like saying sine square 40 divided by sine 40, which will give you sine 40. So we're doing that for one of this, and that would be looking like sine 40 over sine square 30 plus cos 40. Simple. So converting this to decimal numbers and all that, it would be looking like this. Okay, decimal values of this would be 0.643 approximately and 0.25. Sine 30 is 0.5 raised to the power of 2, 0.25. Then cos 40 plus would be 0.7660 and continuously going. So we have cos y over sine y. At this point, everything just sums up to about 3.338. And all of this is okay. I'm going to do one nice thing, of which I believe as a math person you must have spotted it onward to. Let's say reciprocating both sides. If we reciprocated both sides, you would find out that we have sine y over cos y, which is about tan y. Another trigonometric ratio. Please, this is the lengthiness of this is not exciting. I must promise you that. So we have tan y, all right, and is equal to 1 over 3 point that would be giving you 0.29958. So we say tan inverse, or how do you guys call it? Yeah, how do we call it? Arctangent of 0.29958. That gives us an approximate value of y being equal to 16.68 degrees, of which that would mean x from equation 3 would be 40 minus 16.68. So to me, rounding this up to full degree would be 17. And to me, whatever comes out from here should be about 23 degrees. So we have, okay, but then let me give an actual value to this. So we have 40 minus 16.68. That's 23.32 degrees. Okay, so guys, this was really fun, lengthy, and more. And I'm hoping that we get back to doing things like this some other time. It was a pleasure. It was a big pleasure. Thank you guys for watching my video this long, and I hope to see you next time. Bye.